On the morning of June 30th, 1908, in a remote corner of Siberia, something fell out of the sky and released more energy than 1,000 Hiroshima bombs. It flattened a forest the size of Tokyo, but no one would understand what had happened for nearly 20 years. To understand what happened that morning, we have to start with what people saw, because they did see it, thousands of them, across hundreds of miles. Seaman Semenov was a farmer in Vanavara, the closest settlement to what would become Ground Zero. He was sitting on his porch drinking tea when the sky split open. The sky was split in two. Above the forest, the whole northern sky appeared covered with fire. Then came the heat. Witnesses 60 miles away said their shirts burst into flames, their hair singed. The air itself felt like it was burning. Then came the sound, a blast so powerful it knocked people off their feet 500 miles away. Windows shattered, buildings shook, animals fled in panic. Seismographs as far away as Britain recorded the impact. Atmospheric pressure waves circled the Earth twice. For days afterward, the night sky across Europe was so bright you could read a newspaper outside at midnight. Something massive had just happened, but no one knew what or where. Because in 1908, the closest investigators were thousands of miles away, and the place it had happened was so remote, so forgotten by the world, that for 19 years no one would even try to find out what was there. And what they would eventually find would defy explanation for another 50. This is the story of the Tunguska Event, the largest explosion in recorded human history. And what we now know really happened that morning. Russia in 1908 was a country falling apart. The Tsar was struggling. Revolution was brewing. World War was on the horizon. Nobody had time for a forest fire in Siberia, no matter how big. So the event was filed away, forgotten, until a Russian mineralogist named Leonid Kulik picked up the file. Kulik believed the explosion had been caused by a giant meteorite, and in 1927 he led the first expedition to find it. It took them weeks to reach Vanavara, the village where Semenov had been knocked off his porch 19 years before. From there, another 60 miles into the wilderness. And then Kulik saw it. The whole northern part of the sky appeared to be covered with fire. I felt a great heat, as if my shirt had caught fire. Trees flattened in a pattern radiating outward from a central point, as if something had punched the earth from above. But here's what shocked Kulik. There was no crater. No impact debris, no fragments of meteorite. Just an empty zone of destruction the size of a major city, as if the explosion had happened in the sky, not on the ground. Kulik searched for months. He came back in 1928, again in 1929, and again in 1939. He died in a prisoner of war camp in 1942, still convinced there had to be a crater somewhere. He never found one, because, as we now know, there never was one. Decades passed, the Cold War came and went, new tools emerged. Computer modeling, satellite imaging, atmospheric chemistry, and slowly, finally, scientists began to piece together what really happened that June morning. The truth, when they figured it out, was both more terrifying and more familiar than anyone had imagined. On June 30th, 1908, a stony asteroid roughly 200 feet across, about the size of a 20-story building, slammed into Earth's atmosphere over Siberia. It was moving at 33,000 miles per hour. At about 5 miles above the Siberian forest, the friction with the atmosphere overwhelmed it. The asteroid didn't crash into the Earth, it exploded in mid-air. The explosion released energy equivalent to 12 megatons of TNT, roughly 1,000 times more powerful than the bomb dropped on Hiroshima, released in a single instant, over an empty forest. That's why there was no crater. The asteroid never touched the ground. And that's why there was no debris. It vaporized in the explosion. Trace particles drifted in the atmosphere for years afterward, explaining those impossible bright nights across Europe in 1908. What was left behind was the radial blast pattern, the shockwave, the destruction, And the most disturbing question of all, if this happened in 1908, what are the odds it happens again? It turns out more than zero. The Tunguska event wasn't a one-time freak occurrence. Asteroids and comets of various sizes pass close to Earth every single day. Most are tiny, burn up in the atmosphere, become shooting stars. But Tunguska-class objects, 200 feet or larger, are estimated to hit Earth roughly once every 300 years. Most fall in oceans, or in deserts, or, like Tunguska, in remote wildernesses where no one is looking. But if a Tunguska-class asteroid exploded over a major city, say New York or Tokyo or London, the casualties would be in the millions. And in 2003, in Russia, we got a small preview of what that would look like. A meteor exploded over the city of Chelyabinsk. It was tiny, only 60 feet across, about 30 times smaller than Tunguska, but the shockwave still injured 500 people and damaged 7,000 buildings. And here's the thing, nobody saw it coming. Not a single observatory on Earth had spotted the Chelyabinsk asteroid before it hit, because it came from the direction of the sun, where our telescopes, by definition, cannot look. Today, NASA's Planetary Defense Coordination Office actively tracks asteroids. They've catalogued over 34,000 near-Earth objects. In 2002, they tested whether we could actually do something about one, the DART mission. NASA deliberately crashed a spacecraft into an asteroid to see if they could change its orbit. It worked. They shifted the asteroid's orbit by 32 minutes, the first time humanity ever moved a celestial body. It was a tiny step. The asteroid was small, the deflection was minor, but it proved that, at least in theory, we could defend ourselves, provided we see the next one coming, provided we have time, provided it isn't hiding in the glare of the sun. When Leonid Kulik stood in the Tunguska impact zone in 1927, he was looking at something nobody understood. A mystery so deep it took 100 years and the entire arc of modern astrophysics to explain. We finally know what happened that morning in 1908. We know the asteroid exploded 5 miles up. We know it released 12 megatons of energy. We know it flattened 830 square miles of forest. What we don't know is when the next one will arrive, or where, or whether, this time, it will explode over an empty forest. What we now know about that morning over Siberia in 1908 is that we got lucky. It happened in the most remote inhabited region on Earth, where 19 years of silence gave history a chance to forget. Next time, if there is a next time, we won't have that luxury. The sky will split open, and we will see it for what it is.